Hey, sixth grade, we have what I think is a fun lesson today. We are doing something called prime factorization, and that sounds a little more complicated than it is, but this is a skill that will eventually really help you with fractions. So, our two goals for prime factorization are to, number one, recognize prime numbers. We'll talk about those a little bit. And then goal number two, break apart large numbers into their prime factors. So that'll be the prime factorization. And we'll go through a few examples to show you that later. So we start with a lot of red writing, which means it's important to copy it down. For our notes and reminder, a prime number is a number that has only two factors, one in itself. So it cannot have more than two numbers that go into it evenly. So a number like 10 is not a prime number because you can multiply 2 times 5 to get to 10. There are some common prime numbers that we're going to be dealing with today. So look for numbers like 2, 3, 5, 7, 11, or 13. Those are the 6 lowest prime numbers. So all of those numbers don't have any numbers that can go into them evenly except 1 in itself. The only way we can get to a number like 13 is 1 times 13. So we have an example, and I'm going to do this example problem twice because I'm going to show that there are two different ways or multiple different ways you can do a lot of these problems, but we're still going to end up with the correct answer. So I am going to make what we call factor trees. And what we're going to do is we are going to start breaking apart our big number, which in this case is 30, and we are going to break them apart until we get to their prime factors. So all we need to do is think of this 30 as a start of our tree, and we want to find two numbers that multiply together to equal 30. So the first pair that comes to my brain is 6 times 5. And what I do now is I am going to circle any prime number. So I can see that 5 is a prime number. On the left, I know that 6 is not a prime number, so I have to break that down a little bit more. So I'm going to break the 6, and the pair of numbers that multiplies to equal 6 is 2 times 3. And I know that 2 and 3 are prime numbers. Now that I have all of my bottom numbers circled, I don't have any more numbers to break apart. I can write the prime factorization. And I write my numbers from least to greatest. So the prime factorization of 30 is 2 times 3 times 5. And if we redid the math, we could say that 2 times 3 is 6, and 6 times 5 is 30. So we'll always end back up at our correct answer. The reason I'm showing this problem twice is just because some people might have started with a different multiplication problem. Some people might have done either 3 times 10 or 15 times 2. And either one of those methods would get you the correct answer. If we did 3 times 10, we can circle 3 as our prime number. And when we break apart the 10, we're going to break that apart into 2 times 5, because 2 times 5 equals 10. And if you notice, we will still have our same numbers circled. I'm still going to write it from least to greatest. 2 times 3 times 5. And that is the prime factorization of 30. And that would be our final answer. I'm going to do at least a couple more examples. I'm going to switch colors so you can just watch and you don't have to copy it down. So, 45. Well, there are a few different options. I'm going to go with 3 times 15. Some of you might have done 9 times 5. We're going to end up with the same answer. I can circle 3 because that is a prime number. I need to break apart the 15 into 3 times 5, and those are both prime numbers. So my factor tree is done because I have numbers circled throughout the bottom, and I'm writing from least to greatest. Maybe I'm not writing. Trying to write 3 times 3 times 5. Okay, that was painful, but we got there to the correct answer. So it doesn't matter that we have multiple 3's. We can write both of them out. We can have as many of each number as we want, as long as they are prime. And we can recheck this math. We know that 3 times 3 is 9, times 5 is 45. Next example, 80. So even with bigger numbers like 80 or even like 200, our prime factorization is pretty simple. I'm going to choose 8 times 10. So 8 times 10 equals 80. And notice that I cannot circle either of these numbers because neither of them are prime. So I'm going to turn 8 into 2 times 4. And I can circle the 2 because that is prime. And 10 is 2 times 5. And I can circle the 2 and the 5 because those are both prime numbers. I have to break apart this 4 a little more into 2 times 2. And of course, 2 is a prime number. So, looking at when I think of little Christmas ornaments, I have 4 2 circled. Why is this happening again? I have 4 2 circled and a times 5. So 2 times 2 times 2 times 2 times 5 would be the prime factorization for 80. So these factor trees are pretty simple. And if you start breaking apart your number into a different number than a classmate, you're still going to end up with the correct answer. Right? If we started by breaking apart the 80 into 2 times 40, at the end, we're still going to have the same numbers circled. So that is prime factorization, and good luck with your assignment.